and requires 5 merges to build a tree. Now if you see here, first character is B. If first character is B, then the frequency is 2, E is 3. So this is the min priority queue. What is min priority queue they have created? They have created a queue with the minimum value, with the minimum frequency. So B is coming 2, E is 3, C is 5, then F is 7, then D is 13, then A is 70. This is the min priority queue they have created. Right now, these are the single nodes you have. Now you will keep on creating the tree. Now first, if you see 2 and 3 are the minimum values first, that is B and E are the two characters with the minimum frequency. So you take those two characters, that will be your X and Y. So this is your X and this is your Y, B2 and E3, and you merge it to Z. So you add the frequencies of both these. 2 plus 3 is 5. So this becomes your Z. So extract the two minimum node X and Y from PQ. Add internal Z having the frequency 2 plus 3, 5 in the PQ. So we have done that. Right now, you have extracted that. So the remaining nodes are left is Z, F, D, and A. These are the remaining ones. Now, among these, now the next smallest is these are the nodes now which are these are the nodes which were there. So now you have Z added here instead of A and B and E. You have put here Z as 5, right, and 7, E and A 70. So this is what is there. So now you have C as 5. So Z as 5 is there. B and E are removed. Now Z comes here 5, and now the remaining are C, F, D, and A. Now C, which is the minimum, next minimum is C 5. So 5. So your X is now Z, and C is your Y, which you have added. So you add it at the left, and 5 plus 5 becomes Z becomes 10. So Z10 is added here, and these are removed, and the leftovers are F7, D13, and A17. The next which you select is F. Right. Now see, your 10 is always remember that the smallest value will be at the left, and the higher value will be at the right. So now 10 is there and F is 7. So the Z value 10 will come here at the left, at the right, and left will be the smaller value F7. X will be F7 and the Z will be Y. So now 7 and 10 comes in. You sum it and becomes Z 17. So Z is 17 and you remove F7 and you are remaining with D and A. Now from D and A you select D. So 17, again 17 is higher, so you keep it at the left side, and D at the right, D at the left side, and Z at the right side. Sum it, it is 30. Z now 13 plus 7, 17. So now Z is 30 and the remaining is A, 70. Now 70 is higher, so you will keep it at the right side, and left side will be your 30. So now from this 30 plus 70 becomes 100. So Z is 100. Now A, this is also not there in your priority queue. Right. So this is a table which has been created. Extract to so we have extracted the values. Now min priority queue contains single element. The algorithm stops. So this is a single element which remains in the min priority queue. So your algorithm stops here. Right. Each part shows the content of min priority queue sorted in increasing order by frequency. At each step, the two trees with lowest frequencies are merged. Leaves are shown as a rectangle containing a character, and its frequency internal nodes are shown as circles containing the sum of the frequencies of their children B to E intermediate stages. So this is what there. But right now, what we have to do on the left side it is 0, on the right side it is 1. On the edge we have to put it 0 1 0 1. That we have to do. So now in figure 7, traverse the starting node from root node, take an auxiliary array. While moving to the left, child write 0 in the array. While moving to the right, child write 1 in the array. Print array when a leaf node is encountered. So you will put here 0, here 1, 0, 1, 0, 1, 0, 1, 0, 1. On the left 0, on the right 1. So you keep on putting that. Right, they have given here, like here 0 1 0 1 on the right, on the left 0, right 1. You'll put the numbers, then you will create a character set. How A is the first character with frequency 70. The A's code will be what? Where is A? Here. So A's code from the root it is only 1. So your code will be 1 here, only 1. Right now B, where is B? B is here. So what is B's code from the root to B? If we come, so it is how it is done. From the root you have to take 0 1 1 0 0 0 1 1 0 0. This is the code for B, right? And C, what is the code? Where is C? This is C. So it will be 0 1 1 1 from the root. So 0 1 1 1. Then D, which is here, it is 0 0. D is 0 0, and E is this one. So it will be 0 1 1 0 1, right? 0 1 1 0 1. F is this one, 0 1 0, right? These are the codes. Now see how many bits are there. A has 1 bit, so 1 into 70 you are doing. B has 1 2 3 4 5 bits. C has 4 bits, D has 2 bits, E has 5 bits, F has 3 bits. You will multiply the frequency with the number of bits, and that is your total bit. This is how Huffman encoding works. Right. If we see the implementation, so they have made a program in Python. So they have taken class node. They have created a init function inside the class, that is your constructor actually of the class in Python. Self char equal to none, frequency equal to 0. So the character equal to none and frequency equal to 0, they have initialized as a parameter. Self dot char is equal to char, they have initialized self dot frequency equal to frequency. Self dot left, another variable they are taking, left is equal to none, right is equal to none, left and right. And nodes is node as a empty list they have taken. So this was your class, and they have taken nodes an empty list. Def calculate frequencies, right? This is the function they are talking about. Def calculate frequencies word. They are passing a variable word here. The frequencies is an empty. I think this is a dictionary they have created. Dictionary has key and value pair, so I think they have created a dictionary here for char in word. So this word, whatever they are passing here, so from that word means any word you are any word you are taking, right? So that word, this word value you are taking as lossless. This is your word. how many characters are there and how many bits you need to transfer. That is what we need to find out from this lossless. So L is coming 2 times, O is once, S is 4 times, E is once. So that is how many number of characters. So that word lossless, from that one, like for I in word, you can say for char in word, they are taking a variable char. So for from that, suppose the first word char not in frequencies, frequency is equal to word dot count char. So what they are saying is, first you will see that particular character is not in frequencies. If that not in frequencies, right now the frequency dictionary is empty. So that character is not inside the frequency. So it comes here true. It is not in frequency. It comes inside the if condition. Frequency is equal to, so this frequency, which is the variable, is equal to word dot count. So this word dot count is a function char. So you will from this word, you are counting the character, particular character, first character, how many times it is coming. You are counting that. So from L, first is L. So how many times L is coming in this word? So frequency will be set to that, right? And then frequency char is equal to frequency. So the first index of the frequencies dictionary, you will put that frequency character in the frequencies, this, right? Nodes dot append node char comma frequency. So you are appending here this list you have taken, you are appending in this node which is empty. So you are appending means you are adding node char comma frequency. So you are adding node, this class node char comma frequency. That means this char and frequency will be added in this nodes, right? Now another function is def build Huffman tree. Now you are building the Huffman tree while length node is greater than 0. So you are finding the length node until and unless it is greater than 0. Node dot sort key lambda x such that x dot frequency. So you are sorting the list in ascending order of the frequencies. Ascending order means smallest to highest. You are the lambda function. This is a anonymous function which lets you write function in one sentence, right? So key is equal to sort. So nodes sort key is equal to lambda x such that x dot frequency. So according to the frequency, you are sorting the nodes, right, in decreasing, in ascending order, increasing order, smallest to highest. Now that is calculate, that is your this. Then left is equal to not dot pop 0. So what you are doing is your left, this one, this left will be equal to not dot pop 0. You will pop 0 there to the left, and right you will from the nodes dot pop, you will put pop 0. I think it should be 1, not 0. This should be 1. Right is 1, left is 0. Then merged is equal to node frequency is equal to left dot frequency plus right dot frequency. So you are adding the two frequencies, left frequency and the right frequency, and you are merging that. So that is put in the merge from the node class, and merge dot left is equal to left, merge dot right is equal to right, that you have set. Then node dot append merge. So you are adding that in the nodes only, the merged thing. Then return node 0. So you are returning node 0 in from this tree first, the first index. Def generate Huffman code node, current node, and codes. If node is none, return. If node dot char is not none, code node dot char is equal to current node. So you are checking whether that node dot char is not none. So from the codes, what is codes? This is codes. Codes is equal to Huffman encoding word. Okay. Codes node dot char is equal to current node you are setting. Generate Huffman code node dot left current node plus 0 codes. Generate Huffman code node dot right current node plus 1 node codes. So what they are setting is they are to the left node they are adding 0, to the right node they are adding 1, right? And in the Huffman code code they are generating, right? Then def Huffman code word global nodes. Nodes is empty. Calculate frequencies word. So you are calling the calculate frequency here. Then root is equal to build Huffman tree. So you are calling this build Huffman tree. Then you are building it. Then encoded word is equal to space comma join code char for char in word. So you are joining the codes according to the, you are putting a space and by comma you are joining the codes in the word. So you are printing word, the word will be printed which is lossless. Huffman code encoded word. So in the encoded word you are getting your encoded word characters, whatever number of encoding is you are getting. Print conversion table, and here they are printing the codes from the conversion table. So this is from Huffman encoding what they are getting. Let us run this example. So we have the word as lossless. So number of times L is coming is twice. Then O is 1, S is 4, E is 1. So if you see here, if we do it in a Word file, I'm just giving you an example. If we do it lossless, right? So L is 2 times, O is once, S is 4 times, E is once. These are our characters. Right, 1, 2, 3, 4 characters are there, right? And so first we will arrange them according to their minimum frequencies, right? So if we have to do that, so first one is O with 1 as the frequency, then comes E, again 1 as the frequency, then comes E, S with 4 as the frequency, and then comes L with 2, first L with 2 as the frequency, and S as 4 as the frequency. So according to the min priority queue, these are the frequencies what we will get. So if we select first O and E, these are the first two. So if we select O and E, so O plus E becomes 2. So both are at the, so our Z becomes 2, right? So that we have selected. After that, L is 2. So we key L 2 plus 2, Z becomes 4, right? Next is S. So 4 plus 4, so Z becomes 8, right? And if we have to draw it in a suppose here this one is 8, This node, this one will be our root node, right? And I'm creating and left and right, whatever nodes you want to create, left and right. Right. This will be and here the value of z will come 4, and then L. So this way we have created, and now you have to put here sorry, here you will put 0, right? Right, so 0 is there, and here we will put 1. Again we'll copy this, put it here, 0, again paste here, and here again we are picking this, putting it here. So now you have to find out your codes. For S it is 0, right? So if we see in our answer, S is 0, if you see here, right? And then for L it is 0, 1, 0. If L is 1, 0, right? And then O is 110, and 111 is E. O is 110, E is 111. Can you see that?
Yes, ma'am.
Right? This is how the conversion table will be. And Huffman code, how you are finding out the Huffman code is what we had done. So we have to calculate the things also. So how do you calculate Huffman? S is appearing how many times? 4 into 0 will be 0. So if we calculate the so encoding the message M A B E F D A C C, corresponding encoding message will be, so according to that how your message is there, you have to keep your codes there. So your message was lossless, right? So we will keep here. I'm just giving you S is 0, L is L is how much? 0 1. Then O
110.
110, then E 111, right? So your word was lossless. Now keep the values there. L is 110, O is 1, oh sorry, L is 01, L is 01, O is 110, S is 111, again S is 111, L is 01, E is sorry, I have
SC 0, madam.
sorry 01 L, O is 110, S is 0, S is 0, L is 01, then E is 111, then S is 0, S is 0. This will be your encoding, Huffman encoding for the word. So this is how they have implemented it. So in the I don't know, in the question paper, earlier question paper which we had seen for MCSL 216 practical question paper, because theory you don't have to write the program, you only have to write the algorithm. But in practical for ODL mode, they have to do it in their practical session. So this is the fractional knapsack algorithm which they have to do, and this is implementation of two matrices. So implement matrix multiplication. So that is simple program. You can do that with for loops, right? So that is there, and you have to find out how many times inner and outermost loop. This is one of the questions they have asked, right? Is there any other set? Two, 1, 6. Set 2 is there. Set 2 says implement task scheduling algorithm is there. For ODL mode, you have to implement this. So you have to show that. Then this is bubble sort. Bubble sorting you have to do, which we have done in the yesterday's class. These are the two questions. So these kinds of questions will be asked to you. So this is what I was telling you, right? So this was Huffman encoding. So what is given in your this is apply Huffman algorithm to construct an optimal binary prefix code for the letters and its frequencies in the following table. So they are given you A10, B7, 115, M8, S10, X5, Z2. So first arrange them in a particular order of their minimum frequency. So Z will be there, then X will be there, then B, then M, then A, then S, like that, and then I. Arrange them in an increasing order. Then keep on making the tree. Add them, make Z, and then find out the and put 0 and 1 according to that, and find out their codes. That is what you have to do.
Madam,
So
in
there,
this case, madam, in this
yes,
case, when there is A and S, they both have 10 values. So we can arrange anyone at first, or we have to arrange
yes,
it according
yes,
to
yes.
this?
You can put A at the right side, at the left side, and S as the at the right side. A at left, S as right, right?
Then alphabetically, we have to arrange it.
What I in this example also, no, we had C. Uh, which one was there? The in the O and E both are at one frequency.
Definitely, they have smallest values.
Yeah, they are the smallest values. O and
Yes,
one and one both are same now. So I have kept
yes,
O at the left. The first one O is coming first now
yes, madam.
in lossless. So on the
Yes,
left I have kept O and E at the right
yes.
side. So same way,
Okay.
the same values if you are getting in your question, in the same values if
Hmm.
you are getting 10 and 10 frequency, so A on
Hmm.
the left side, S on the right side.
Okay. And one thing more that there, when you were calculating that Z, please explain that point, that how to calculate
You
Z
are
after.
adding these 10 plus 10, you are
Yes.
adding these frequencies and keeping it in Z. You can keep any other
Okay.
value. If you have Z here, you can keep any other
Yes.
variable.
Okay.
That
Okay.
is a separate issue. So we are adding it. See here.
Yes.
The frequency of O is 1, E is 1, add it. The Z
Yes.
is what?
Two.
2. So this is
Okay.
the Z frequency we are keeping here, right? 2.
Okay.
Then
Yes.
we have to add, we have to see now the next frequency is L,
Yes.
right? So
Yes.
I am keeping it at the, because again L has the frequency 2 and Z is also 2.
Mm-hmm.
So I am keeping it at the left side, L,
Mm.
right?
Right.
So,
Right,
so
ma'am.
L is 2 and Z is 2, 2 plus 2 is 4. Z becomes 4
Okay.
now, right?
Okay.
Now the next
Mm.
one which is left is S. S is 4.
S.
Both are 4. So I have kept it at
Yes.
left side. S is kept it as left side. So now
Mm-hmm.
4 and 4, how much will that be? 4 plus 4 is
Eight. Eight.
8. That is what is the root, the final thing.
Okay. Okay.
This is how Z is calculated, right?
Right, madam. Thank you.
So they have given you number of questions. The file contains colons. Now this is again they have given you. So they are saying colon is 80 times, space is 500, new line is 110, comma 500, 0 is 300, 1 is 200, 2 is 150, 3 is 60, 4 is 180, 5 is 240, 6 is 170, 7 is 200, 8 is 202. Again, these are the characters, and these are its frequency. You have to make a table and show it what will be the encoding for that. That is what is Huffman encoding, right? This is what you have to implement. But for the theory examination, which will be in June right now, practical will be in end of July. That will be a separate date sheet, a separate thing which will be told. MCOL will be a Viva based practical. MCA ODL have to go to the center and they will be given the question paper I was showing. This type of a question paper will be there, right? So you have to do it on the system provided by the center. So these are the things you should keep in mind, right? Now we have another class again, right, at 12 p.m. What we will take is we will take half an hour break, right? We will come back again. Yes, Gunjan, are you asking some question? You have raised your hand. If somebody has some questions or something,
Madam, how do we, madam, excuse me, madam.
हाँ जी,
How do we prepare this lab record for this?
I told you ना, solve this any, see, I told you that the first question has different kind of questions, so you solve them,
Okay.
right? Give the coding for them and give the output screen for them,
Okay.
right? And the session number 2 fractional knapsack, you have 3 questions, do any one question,
Yeah.
the program of that and the output screen of that. Again, session 3, you have task scheduling algorithm. You have question 1, 2, 3. You do the third, any one question. Third question you do it and show the coding and the screenshot. Huffman coding also, session number 4. You have 4 questions. You do any one question. Solve. Show the code and the output screen. That's all. Right?
Send
मैम
it to.
जो
What? Yeah, anybody was asking what is the question?
One thing I want
Hello? Do you have any questions? Answer.
मैम मैंने जो लैब रिकॉर्ड जो बनाना है वो आपको भेजना भी है ईमेल करके लास्ट में।
मेरे को नहीं भेजना है ईमेल करके, आपको आपके प्रैक्टिकल के अंदर, प्रैक्टिकल आपने असाइनमेंट देखा है अपना?
हाँ वो मैंने सबमिट भी कर दिया ना।
प्रैक्टिकल असाइनमेंट में आपको दिया हुआ था, प्रैक्टिकल असाइनमेंट में कि आपको आपका जो असाइनमेंट के क्वेश्चन 20 मार्क्स का ईच सेक्शन है, मतलब पार्ट 1 इज डिजाइन एंड एनालिसिस ऑफ एल्गोरिथम, पार्ट 2 इज वेब डिजाइन लैब। तो मैं पार्ट 1 की बात कर रही हूँ, पार्ट 2 का भी वैसे ही है। पार्ट 1 का जो 20 मार्क्स है वो तो आपके असाइनमेंट के क्वेश्चंस का है, बाकी 20 मार्क्स आपके लैब रिकॉर्ड्स के हैं।
मैम ये तो सबमिट कर
लैब
दिया मैंने
रिकॉर्ड्स
असाइनमेंट।
उसके साथ अटैच करने थे असाइनमेंट में, मुझे नहीं मेल करना है।
मैम वो सबमिट कर दिया, अब कैसे होगा?
आप कौन से मोड के हो, ओडीएल या ओएल?
ओएल मोड।
ओएल। अगर आपने आपका एलएमएस पोर्टल खुला हुआ है तो आप दोबारा ट्राई करके देख लो अटैच करके, अगर अटैच हो जाता है तो। कहने का मतलब है कि दोबारा से एडिट करके एक नई फाइल बना के देख लो, अगर ऐड हो जाता है तो।
मैम एक बार सबमिट होने पे दोबारा उसको नहीं कर सकते चेंज?
हाँ, मतलब अगर नहीं हो रहा है तो फिर नेक्स्ट टाइम कर लेना। अगर आपको मार्क्स मिल जाते हैं तो वेल एंड गुड, आपके मार्क्स अपडेट हो जाते हैं तो वेल एंड गुड। अगर बाय चांस नहीं होते, आपको कम मार्क्स मिले हैं या आपको फेल कर दिया गया असाइनमेंट में, तो सेकंड सेमेस्टर में दोबारा सबमिट कर देना विद द लैब रिकॉर्ड्स।
ठीक है मैम, थैंक यू।
मैडम ये जो लैब रिकॉर्ड्स के लिए आप बोल रहे हो, ये 216 का जो हमारा टेक्स्ट मटेरियल ऑनलाइन अवेलेबल, इसमें जो क्वेश्चंस है वही सॉल्व करने हैं?
हाँ जी, MCSL 216 के। मैंने इसीलिए बोला ना कि क्वेश्चन नंबर 1 में तो डिफरेंट क्वेश्चंस हैं, मतलब क्वेश्चन नंबर 1 कह रही हूँ कि सेशन नंबर 1। तो सेशन नंबर 1 में डिफरेंट टाइप्स ऑफ क्वेश्चंस हैं, उनको सॉल्व करो।